everyone who just joined us. I'm going to continue the discussion about the charging system. And I would say the important part of the charging system is alternator. I've already covered the battery in the previous sessions, which is important topic. You are going to just have some question from the battery for your midterm exam. Make sure you review the battery part and be prepared for the midterm exam. So before everything, I'm gonna just explain the structure of the alternator. I'm gonna share my screen. You can see on my screen there are two types of structure for the alternator. It could be Y connected shape, or it could be delta. For the Y also we use a star, so we call it either Y or a star, and delta or triangle. So we have either of them. Either of them is a good one to learn about. When they say Y, it's the same as a star and delta or triangle. These two are the same. So there is difference between the connection. Although there are some common specification for both of the styles. If it is a Y style, of course, we have like 3 winding. In fact, alternator is supposed to generate AC current, right? If we have a single wire in there, we are going to have only one single AC being generated. Therefore, this is going to be considered a single phase. But in situation, we are having 3 wires. As you can see right in here, we are going to generate 3 AC current. And if we are generating 3 AC current, then we call it 3-phase. So that's what we have as a 3-phase. Another important factor, when we are having a Y connection is going to, in fact, have higher AC output. Therefore, also we have some neutral wire in case we are having a Y connection. So we have higher voltage output. I'm gonna summarize it in here. We have higher voltage output. This is one of the benefits. Another one is we are going to have a neutral available while we do not have a neutral for delta connection. Another factor for Y connection is going to be we have less insulation. We do not need too much of insulation needed. So less insulation. You may want to take your note or later watch the recording. And of course, this is going to be mostly used for diesel like application. Therefore, diesel engine. Therefore, this is going to give us high voltage. This is going to give us high voltage, this kind of connection. And of course, low current. So high voltage, low current. That's why I would say having a Y connected stator is more efficient than having a delta connection, right? But what's the difference with delta? With delta, first, we do not have neutral. So I would say no neutral. That's what we have in here. We have higher current, which is opposite with the Y. In Y, we have low current. But in delta, we have high current. And of course, in here, this guy is better for a heavy load supply, right? For heavy load supply. So if I want to now to just summarize what is the characteristics of a delta connected stator, I say delta is giving us low voltage and high current. Y connection is giving high voltage and low current. That's the difference between these two. So in addition to that, now we are going to look at the rectifier. Now, rectifier, in fact, is a diode, and diode is a kind of semiconductor. I've already introduced semiconductor. So now you are having a diode, which is a rectifier diode. And this is going to allow any electrical current to flow in only one direction, right? So we usually use it in order to handle the higher current flow inside the system, because this is going to change the alternating current into direct current. So it's gonna convert the AC to DC. That's why we say it is going to flow only in one direction. So they are designed as like discrete components, and they are going to be integrated inside the circuit in order to even sometimes they need thermal management, and they have fan in order to do some thermal management as well. So they are usually in series connection to increase the peak voltage, which we call it PIV, or peak inverse voltage. This is peak inverse voltage. So we use them in order to do so. Now, alternator output is dependent on multiple factors, which you can see right in here. But most a specific factor in like among all of this is a speed and temperature. Speed and temperature, but there are more. I can name some of them. So it depends on the number of the factors, such as the battery condition, such as the speed, the wire size, engine horsepower or RPM. It could be also dependent on the battery temperature and alternator temperature. But as I said, the most important factor which can impact the functionality of the alternator is the RPM or a speed, and the temperature of the alternator or temperature of the battery, either of them. So alternator in fact rotates at a speed of, I would say, 2 to 3 times faster than the engine speed. Whatever the engine speed or the RPM is, alternator must always, it will open at 3. Take a picture and yes, and I didn't customize it for you. Just take a picture and it's gonna remain open till 3:30. Yeah. Thank you. I believe you have enough time to submit it. Yeah. No worries. You are good to go. Sorry. So what I was talking about, alternator, I was talking about alternator wall. In fact, a speed in 2 to 3 times than the speed of the engine. For example, whatever RPM you have for the engine, this guy supposed to spin super fast, like 2 times of or 3 times of that one. Now, having this in mind, look at this part. As I said, there are multiple factors which are important in the functionality of the alternator, and one of them is the strength of the magnetic field. For example, in order to somehow boost or in order to control the alternator, if you want to control it and if you want to boost it, definitely we have to just increase the number of the turns of the conductor wires. This is one way. And of course, we can increase the current through the rotor. This is how we can increase the alternator, right? Now, if we know how to increase the alternator output, if this is the alternator output, and how we can increase them, therefore we can increase them by increasing the number of the wires or by increasing the current through the rotor. Now, if we know how to increase it, of course we have to be able to control it, because if we increase it and we are unable to control the voltage, definitely we are gonna damage either the battery or other electrical component in the system. And in order to do those control, I need to introduce another component in here, which is called the voltage regulator. Probably here and there in other circuits, you experience using other voltage regulator in a different format, but the one that we are using for the automotive application, this is how it looks like. And in fact, voltage regulator in here is going to help to control the output of the regulator and make the output of the alternator and make sure it's also in the like acceptable range for that one. Acceptable range in here is a factor of the battery rate which we are using in the automotive application. Here you can see I have like this voltage regulator range, which is like a graph showing how the voltage range should be. For example, this line in here, this is something at around 14.5 volts. And in situation that we are above this, definitely we have to turn on a load and get rid of any excess voltage. And situation that we are below this range, if we are below the range also, we are going to have a weak battery. So we have a discharged battery, and we have to either fix any problem. If it is a problem, replace the battery. If the problem is something that we cannot troubleshoot it, we have to replace the battery. Therefore, you have to have this understanding. So you have to have the acceptable range, this blue one, to be at around 14.5. Anything above or anything below, usually below is at around, I would say, 13.8 volts. So if you have something at around, or let's say below 13.8, then your battery is weak and it's time to replace the battery of your vehicle. Have that in mind and consider this is the same battery which I'm talking about. And if I'm going to highlight this part, look at this part which I'm highlighting it in purple. This is the circuit which is important, kids. This part, pay attention. This is going to be one of your questions which might be inside either midterm exam or inside your final exam. So this part, this kind of circuits is important to understand them, the components inside them, and of course the functionality of each component. It could be a question for the theory part of your exam. Therefore, pay attention. So this is the alternator circuit. I'm gonna show the alternator circuit with yellow. This part which I'm showing, this is the whole alternator circuit. And then what I show, so I'm gonna clarify this one. This is the alternator. And the one which I show with the purple, this purple one is your regulator. So pay attention. Now, what is the relationship between the alternator and the battery? And then, of course, what is the relationship between the regulator and the battery? And which one of this is going to really impact? So here, voltage regulator supposed to, as I said, supposed to control the voltage and make sure anytime we are above or anytime we are below, this guy is supposed to compensate for that part. So it's going to, in fact, keep the battery voltage within a safe range. And I said that safe range is something at around maximum 14.6, minimum 13.8. Anything out of this range is going to be non-safe range. And we have to troubleshoot the system and figure out what the issue is. Now, this regulator in here is supposed to adjust the current to the rotor. You can see my stator is in here. You can see, for example, this one is the rectifier bridge. And this one is the part which I'm talking about. This is going to be your regulator. And right in the battery voltage, if you check this one, if the battery voltage is dropped or it is below the acceptable range, which is below the like 13.5, 13.8, it depends. As I said, it could be adjusted based on the type of the battery included in the system. Then regulator will close the system. After the regulator will close the system, what will happen? It will activate the whole alternator, which is shown in yellow, right? And right after that, this is going to also strengthen the magnetic field in here. And right in there, we are going to have like some power to be sent to the battery in order to charge the battery. You got the point? So this regulator has the job for you in order to charge the battery whenever your battery is below the acceptable range, right? So it will close the system, this one, it will close the system, and then your alternator become the charger for the battery. And otherwise is what? Once the battery reaches that acceptable charge or maximum voltage that you need for the battery, which is something between 14.5 or 14.6, something like this, again, based on the battery spec, then that's the time that regulator will disconnect from the battery not to overcharge the battery and damage the battery. Make sense? It was easy for you to understand what's the application of this regulator inside the alternator circuit. So you need to understand regulator is a part of the alternator circuit. And in addition to that, what is important in here, pay attention, this is the regulator circuit. Inside this regulator circuit, I'm having multiple electronic components, such as MOSFET or FET. So I'm having a FET in here, and I'm having multiple diodes in here. One of these diodes is super important, which is the one which I'm gonna just highlight it with green in here. This D2, right? Which we call it Zener diode. This Zener diode, may I have your attention? This Zener diode in here is really important. So it is going to act as a voltage reference. I'm going to write it down in here. This is going to be as a voltage reference, and it will work like a switch in order to turn on and off the regulator, right? Anytime that we are over voltage or we are below the voltage, in fact, remember I said regulator is supposed to disconnect and then let the alternator to charge the battery if the battery charges below. And in fact, that's like functionality is happening through this Zener diode. So the Zener voltage will go on and off. It will like act as a switch to turn the regulator on or off based on how much voltage we have inside the battery. Make sense? It was clear? Therefore, if I ask you what's the application of this Zener diode inside this circuit, also I'm having other diodes as well. Now you have to answer it like this. This Zener diode acts as a voltage reference for the regulator, and it will act like a switch to turn the regulator on or off based on the situation of the battery voltage. If battery voltage is low, it should be off to let this one to charge the battery, and otherwise. Simple enough to understand for everyone? So next, I took a screenshot from this regulator. I added into here to introduce a little bit more. Remember I said it has like some FET, right? Some MOSFET, which is this one, which is transistor, and it has like the Zener diode. But in addition to that, it has thermistor. Thermistor is another sort of resistor which is sensitive to temperature. Means it will adjust based on the temperature. Makes sense? Therefore, in here you can see in addition to Zener diode, in addition to transistor, we are having temperature sensitive resistor in here in order to also regulate the voltage. How? In fact, also it is going to react to the temperature in order to become activated, but it is going to regulate the voltage. You all know that if I'm having a little bit of excess voltage and I'm applying some resistance to the circuit, resistance acts like a load in order to get rid of any excess or extra voltage. Makes sense why we have thermistor in here now? So since this is regulator, and since it is going to experience different rate of voltage, definitely it may generate some temperature inside, right? And since it is generating temperature, we need something to detect that high temperature and adjust the resistance accordingly. That's why we are including a thermistor in the voltage regulator circuit in order to stay in the safe range for the battery voltage. Make sense so far? Easy to understand? Yes or no? So, next is going to be about, as I said, I'm trying to simplify them also, each of this topic for anyone who's really interested in advanced electrical application in automotive engineering. For automotive engineering, most of the electrical application are super advanced. Anyone who's interested, at least I'm trying my best to simplify the concept. Later, if you want more, you can go expose yourself to more understanding of the circuits that we are using inside automotive electronic. Another one is the cooling system. Well, I just said it. We are going to look at the voltage, and since the voltage inside the system is going to change, definitely anytime that we have a little bit more voltage, some of the components inside the system may generate some heat, right? Therefore, we are going to include thermal management system. Thermal management system in order to cool down the system, because anytime we are having too much of temperature, definitely it might create some dangerous situation. We have different cooling type, right? One of them is the external fan, and usually when we are having a fan, in order to cool down the system, either if it is the engine or around the engine, or if it is the battery, we call it active cooling, right? How many of you are familiar with active and passive cooling? Last week teaching the battery, I touched the, I would say the concept, but again, active cooling is, I would say, any external cooling system, right, which we are installing for cooling any type of component, such as battery, motor, engine, something like that, such as fans, such as liquid cooling. These are what we call them active cooling. And passive cooling, there are another method of cooling, such as phase change material, which is like a wax we are applying around the battery. And why we say phase change? Because initially it's solid. As soon as the temperature inside the battery is going up, that solid will change to liquid. That's why we call it phase change material, or PCM. PCM, or phase change material, which is the coolant technique. We call it passive cooling, and so on. So in here, we are having mostly active, because this is about the engine part. So we are looking at external fan or internal fan, and maybe some coolant cool. These are some methods that we are using in order to get rid of any extra heat around the alternator. So in addition to that one, I'm going to look at some computer controlled charging systems. Since I just touched the word PCM, and I did it by purpose, do not confuse the PCM that I talked about right in here and the one which I'm going to talk right in here. PCM in here is phase change material, which is a type of wax which we may use it for cooling any system such as batteries, right? But even not for the alternator. For the alternator, we do not use phase change material, but for battery we use. But the one that in here I'm talking about, this PCM, is powertrain control module. In fact, this one is a active, it's going to be connected to any active charging system. And do you know how we activate the charging system? I already said it. We can turn on the headlamp to activate the system. After we activate the system through the headlamp, why we do so? I said it last week, last session. In order to get rid of any extra charge. Remember I said when you jump start your vehicle, it may store a little bit of extra voltage, which is normal inside the battery. And in order to get rid of that, you have to turn on your headlamp in order to get rid of that and get the battery to stay in the safe range. Now in here, we are going to use PCM to turn the charging system on and off by controlling the field current to the rotor. So we are looking at the field current to the rotor. This is important in here. So we use the PCM signal, and we are looking at the duty cycle, and based on that, we can understand how much field current is flowing through the rotor, and that's what it is done through the PCM. You can see right in here, I have the duty cycle, and I have the alternator output voltage, which is measured using your multimeter. So based on that, you can just measure it. So in here, I also mentioned it is going to monitor the flow of the current inside the rotor. Another thing that I have as an example, I leave this part, the detail for yourself to study, but I'm going to touch it in here. You can see the this is the GM electrical power management system mood, because companies may have different a standard for themselves. For GM, they have charge mode, voltage reduction mode, battery sulfation mode, fuel economy mode, startup mode, and headlight mode. So in any of them, they do have some standard to consider. For example, the one in here, the headlight, since I just talked about headlight, if they are using the headlight mode, they have to look at the target voltage to be at around 14.5 volts, right? Next, I'm going to look at some testing quickly, and then we will close it right in here, and we'll go for the assignment. So look at here, there are multiple methods in order to test the functionality of the charging system For most of them, we are using regular multimeter. For some of them, we are using another light tool in order to use the light to look at the functionality. I'm going to show it. If we are using the regular multimeter, we have to make sure it is set to DC volts and look at the DC voltage. We have to start the engine and we have to press the gas pedal to increase the RPM and bring the RPM up to around 2000, right? And then we have to connect the multimeter and we have to make sure the battery is charged up to at least 75%. And the speed or the RPM is at around 2000, and then we can read the voltage, and based on that we can look at the functionality of the charging system. So a specification for charging, if you want it to be in a good functional mode, it has to be something between 13.5 to 15. Anything out of this range means we are having a faulty system and we have to troubleshoot it. Another one is the voltage drop test. Voltage, again, we are using multimeter, but the thing is we have two methods. Either we are looking at the positive or negative. If we are looking at the positive, we have to connect the battery positive to the alternator, right? And then we have to read the voltage accordingly. If we have like at least 0.4 volts, we are in a good mood. Otherwise, we have some trouble and we have to troubleshoot. Another method again is connecting it to the negative of the battery. And of course, from there, we have to look at 0.2 if we are looking at the negative of the battery, if we are at around 0.2 volt. And definitely we have to look at the speed or the RPM. It has to be 2000 RPM. Then we are having a functional system. Otherwise, it is going to be troubleshoot. Another one which I'm gonna explain it is a scan tool. So far in the previous test method, I was using multimeter. In this one, I'm using a scan tool. This is important when we are using a scan tool. In fact, this one is going to again look at the field current voltage and output voltage, right, through the rotor. Therefore, I have to make sure that I energize the field current. I said it, again, I repeat it. In order to energize the field current, you have to turn on your headlamp, right? Your headlight, because headlight in here is going to act as a load. In order to look at the voltage, we have to have the headlight to be on to activate the field current, and then we have to connect this one and read the voltage accordingly. Another method is mega fuse or feasible link. Feasible link is a tool which is working based on light. We are connecting it to the alternator, as you can see right in here. This is the feasible link. This is a tool which is operating based on this light in here. It can detect the light, and then based on that, we can check the fuse and see if we are having a functional fuse or if we have a faulty fuse. Another method is going to be diode test. In this one, alternator, in fact, is going to always give us AC. So we are looking at the ripples, right? And if we are having a normal AC ripple, it simply means we have no faults. But if you are having some defective alternator, the ripple is not organized. The ripple are like something weird, which you can simply looking at that understand you have a faulty alternator. And of course, the last one is diode test. Diode test, again, you have to be on AC mode. You have to consider 2000 RPM. You have to connect your multimeter to the battery. And then, of course, you have to turn on the headlight to activate your system in order to measure. And if you have something at around 0.078 volt, means your system is a good one. Otherwise, your system is faulty. And this is the last one, which is a carbon pile test. This device, I show it in previous session inside the video. It's the same one. Remember, I said there are two clamps, and this clamp, they are connected to some hose, and they are supposed to control the pressure of the clamp based on this one. So they are a stacked resistance in there. Therefore, they are going to, in fact, they are low. That's why I say a stacked resistor inside. They are low. They connected to the system, and they are going to control the pressure through this, and they can read this one. If they start the engine start at 2000 RPM, definitely it's a good one. Otherwise, they have to increase the load, and they have to make sure that the drop below 12.6 is gonna be a faulty situation, and they have to compare the healthy operation with non-healthy operation. If anything, replace it. So this is it. And I'm having a little bit of multiple choice question, as I said at the beginning. You can review them on your own and ask me any question. So before I start the assignment, if you have any question, feel free to ask. Otherwise, we can start the assignment.